Continuing on with geometric sequences, given the following example. Bacteria are single-celled animals that divide into two to reproduce. Suppose you start with 5 cells in a petri dish. Under the right conditions, the cells should divide every 30 minutes. So every 30 minutes, each of these cells is going to divide and basically split in two. So what happens is, to write the first 5 terms of the geometric sequence, well, my first term would be 5. That's the number of cells I'm starting with. If each of these cells divide and cut in two, after 30 minutes, I'm going to have 10 cells. And then after 1 hour, if each of those cells split in half again, I'm now going to have 20. And then 40, and then 80, and so on. So those would be the first 5 terms of my sequence. If I wanted to write the general term for the sequence, remember T of n represents any term value in the sequence. So I just want to write a general term or a general rule to represent this geometric sequence. So T of n, remember, is our first term times our common ratio to the n minus 1. So from my sequence, I know my first term is 5. My common ratio was 2. And this is simply going to stay to the n minus 1 because n is unknown. We don't know what term number we're looking for. We're just looking for that general term. And that would be our general term. Question C, find T of 12. So I want to find the 12th term in this sequence. So to find term 12, I'm going to substitute 12 in for my n value of my general term. And when I do that, I get a value of 10,240 cells. So the question is, what does this number represent? So because this is T of 12, initially we want to think of this is the number of cells in the dish after a certain amount of time. And initially, because it doubles every 30 minutes, if we cut this in half, we initially want to say 6 hours. But we have to consider what our first term was. 5 was our first term, which is not the number of cells after 30 minutes. It's actually the initial amount of cells that we started with. So if you consider this is after 1 hour, this is after 2 hours. So I've actually gone through 5 terms to get through 5 hours, or to get to 2 hours. So this would be the number of cells in the dish after not 6 hours, but 5 hours and 30 minutes. It's always going to be a half an hour less than what that term value is, because T of 1 represents the initial amount, not the amount after 30 minutes. What will the bacteria population be after 9 hours? Well, again, 9 hours right away, because it's doubling every 30 minutes, we're thinking we're going to find T of 18. But again, we got to think of this initial amount. We can't consider this, and our terms is always going to be one more than what we think it should be. So in this case, 9 hours would actually represent T of 19. So sometimes it's a little bit tricky when you're working with problem solving questions. You really have to think about the question and think about what term number are you looking for to represent what the question is asking. Okay, so here we're looking for T of 19, so we're going to go 5 times 2 to the 19 minus 1. So the 19th term, or 9 hours, gives us a value of 1,310,720 bacteria.